Hello everyone. My name is Kamel Rushaidat. I'm a senior software engineer. Today I'm going to go over introduction to object-oriented and C#, and so let's get started. So to start with object-oriented, it's a one way of programming which depends on viewing everything that we deal with as an object, and this object has properties and behavior. So these properties do represent the data that is basically inside that object. So for example, if we take an employee, that employee has a first name, last name, salary, etc. And behavior, for example, is printing the information of that employee, getting a salary, something like that. So I'm going to first explain some of the concepts that we deal with in object-oriented, and then I'm going to give you an example on using object-oriented in coding. So object-oriented has four main concepts: abstraction, encapsulation, inheritance, and polymorphism. Abstraction is basically just hiding the details and showing the functionality. And basically this is done in object-oriented using methods. So inside the method you write all the code you want, and then just basically expose that as the method's signature. So once you start using that code outside that class, it's just basically using that method name. Most of the time we don't care about the implementation. It's really like when you use your phone for a phone call. You don't care about like how the internal process goes on. You just want to do that phone call. As for encapsulation, object-oriented made that really easy by defining something we call a class. So inside, for example, one class, you define everything related to an employee, from all the properties and the methods, and you just put them in one place. If you want to define something else, for example, like a manager, you define another class, and then you put everything there that is related to that manager, and so on. Inheritance is a really powerful, I would say, concept of object-oriented. In this concept, basically, a class can acquire the properties and the behavior of another class, which is in this case called a parent class. So it has this feature and basically it provides code reusability. So for example, if you have a class called employee and then you want to make a new class called manager, you can't imagine that a manager is still an employee, so you can reuse everything that you defined from that class, which is called the employee, and then add some stuff that is very specialized to that manager. And from inheritance you can enable the next concept, which is called polymorphism. So polymorphism here is a concept that makes us deal with a class in multiple ways, or let's say in different forms. So for example, when you have two classes, one is called like manager and another one is called an employee, you can always view a manager as a manager, and also at the same time this manager is an employee. So at the same time you can view one class as, let's say, two more entities or even more than that. So in this example that you see in the slide, an employee is a person, and let's say in another format, a dog is an animal. Also you can say, for example, a square is a shape, and also a triangle is a shape. Now it may seem a little bit vague, but here I would say polymorphism is a very powerful concept. It's used in many, let's say, code solutions for a lot of problems. Again, we had talked about the polymorphism concepts. Now, getting to the million-dollar question, class versus an object. So, in a really simple term, a class is just a template or a blueprint that is going to describe the behavior and properties of many objects. So, for example, when you design a class that is called an employee, you're basically putting the behavior and methods for all the employee objects that you can make. It's very similar when you design things in real life, like let's say you have a blueprint for a car or like a phone. So you design everything in that car and you design how it's going to work, etc. At the end of the day, it's just a design, so you can like use that to describe how the car is going to work, but actually you didn't build a car. Now the object itself is the instance of that class. So once you start making those objects, you're just basically going to that template and using everything described in that template to make that object. In real life, for example, when we talked about the car example, basically you go there and make an actual car based on that design. From that design, you can make thousands and thousands of objects. Each one can be different in terms of its properties. So for example, when we have many employee objects, each one can have a different first name, last name, etc. And we call that the state of that object. So you can have 1,000 objects and each one has a different state. And all these variables, we call them like instance variables, and basically they have data types. Each one has its own definition, and the values for these instance variables are going to be different when you have different objects. And usually when we define these instance variables, you want to keep those variables as private. So you want to use this keyword to hide them inside your object, and then you want to define a certain way to access these variables. So for example, when you talk about a salary inside an employee class, this salary shouldn't be just exposed as a public variable, because there are rules of that actually, I would say, govern like how this salary is going to be controlled, like in terms of how you give it, how you increase the value of the salary, how you give bonuses, etc. So usually accessing those variables are done using something called properties in C#, and you can assign them initial values using something we call a constructor. A constructor is basically just another method that is used to initialize the values of an object once you make it. So I'm going to move now to give you guys a really quick example on how to make a class inside C# and how to make an object of that class. So if you go to your Visual Studio, File, New, Project, and then you can select .NET Core. I'm going to select Console Applications, .NET Core. I'm going to go here and call it Test Object Oriented 2020. Okay, so as with any other application that you have made, usually there is a program.cs, and if you see, your code is already enclosed inside a class. C# is object-oriented, and that means your code should be always written inside a class like you see here. Now we're going to start defining our own classes inside our project. So I'm going to create a simple class called employee and define some properties inside it. So I'm going to go here to my project test object oriented 2020 inside my solution explorer, right click, new, and then I'm going to select class. So this is the class I have selected. I just need to give it a name. So here we're going to call it employee, and then you just need to hit add. Now you can see that class employee is inside namespace test object oriented 2020, and this is the same namespace as we have here in program inside the program.cs file. So that means both classes can see each other. So if they're in the same namespace, even if they're like in two different files, they can still see each other. Okay, so usually when I start defining my own classes, I start with the instance variables. We can define maybe a number of these. I'm going to keep it simple, so I'm going to start defining a instance variable called first name, like that, and I'm going to make another one called last name. Okay, and as we stated before, usually these variables should be defined as private. Usually here in C# the default access modifier is private, but usually I prefer that you make it explicit and actually go here and define it as private. And usually these variables, when they're defined as private, that means they can be only accessed within the class that is called employee in this case. However, if you keep it this way, nobody can access these variables from outside. So we want to give them access, and usually this is done in C# using something called properties. In other programming languages, for example, like in Java, you need to define actual methods that do set and get values from these variables. In C#, they do it in a different way by using something called a property. You can write it by hand, but also Visual Studio provides you with a lot of refactoring tools, and one of them is basically used to build properties off of these variables. And to do that, all you need to do is to go to this variable, for example, like first name, and then you can right click on it and then use quick actions and refactoring over here. When you come here, now you can like just choose encapsulate the field and just the first one, and use the property. So I'm going to click on this, and then I'm going to do the same thing for the last name. Now, this is a new way of defining properties in C# if you have older books, or like maybe if you look on the internet on like maybe older tutorials, they're going to be maybe defining this in a different way. But here they use arrow functions to define them. Basically, we have a set and a get. So the get returns the value of the first name, which is this one, and the set actually gives a value that comes from outside the employee. These two let's say operations, the set and get, are optional, so you can remove one of them. In case if I remove the get, it's going to be just set only. If you remove the set, it's going to be get only, which is somehow like read only. Now, whatever like you assign or read from one of these properties is going to go back all the way to these two fields over here, the first name and last name. Now, most of the time you're wondering maybe why are we even using this? The idea here is actually more advanced. Usually we add validation or control like how we set and get variables. So for example, if you're talking about a salary, like when you set a salary, maybe you're giving like bonuses or something like that. So usually the operation here can be modified. In terms of like how we control access to these variables, usually the variables themselves or the instance variables are protected by using the private, and the properties act like the validators or like the guardian for like these two variables. And this is a really good practice in terms of programming. Usually you need to do this by defining properties for like the variables that you have. Now I'm going to add so this is where like we define the variables. I'm going to add a really simple method that uses these two variables. So I'm going to define public string, and then I'm going to call it get full name. So here I have a method called get full name that doesn't take any parameters and returns a string. Again, I'm going to keep it really simple, so I'm going to return first name plus maybe like a space here, and then last name. Now usually every time I refer to first name or last name, you should be always using properties, just so you always like go through the validation or whatever like mechanism you build inside these properties. You always need to use them. If you use the first name and last name over here, basically you're just bypassing all those mechanisms that you have built. So I think you can also add some comments maybe here. It's a really good practice. And I'm going to have here just like this. Okay, once we're done, you can just hit save, and you can obviously like add more comments as you want. Like maybe you can define what these variables are about and what this method actually does. Okay, once I'm done here, so I have designed my class. It's a template, but this is actually now not used in any way. Once I start making objects, this is when like all of this comes to use. So I'm going to go back to program.cs. I'm going to remove this constant message and define an object of this class. So usually when we define objects from a class, we start by putting the class name, which is employee, and then I'm gonna make a variable name, for example, called employee1 equals new employee. And then we're gonna finish with this over here, which is called like the constructor code. So we're gonna come back to this maybe in later videos, but basically this is a way to initialize your object. Now obviously here it's not taking anything, so it's using something called the default constructor. The new keyword here is the keyword in C# that actually creates objects. So it goes to the design that you made, follows what you have put here, and then goes to the memory and makes an object from that design. Goes and creates the variables, the methods, and puts them there. When you use the default constructor here, it's going to go and give default values for any variables that you have. In case of strings, it's going to give them an empty string. If you have integers, it's going to give them a 0. And then if you have like other types, it's going to basically just give them their default values. Okay, so coming back here, I can actually go and say employee1, and then we're going to use the dot operator to access all these variables that we have made plus the methods. Also in next videos, maybe we're going to talk about where these other methods came from, although I didn't even write any of them. Okay, so going to first name, let's just give it, let's say John, employee dot last name, Paul, like this, and then I can just reuse any of this inside line. Just say employee1, and then I can use the method that I just wrote and say get full name. Okay, so really quick, execute this program, and then you can see that it basically wrote John Paul. Now if I make another object, just copy these so I can reuse some of this code. Gonna make another variable called employee2, and always don't forget to update everything if you copy and paste. Now this is a different object called employee2, and it has a different state, so Mary Adams. And now if I go and call like full name for that object, it's going to print Mary Adams. So now I have two different objects defined from the same class called employee. They both have first name and last name, and we called the full name from each one of these. Okay, so I hope you learned something new about object-oriented, and I would like thank you for listening, and talk to you later in the next videos.